Hello. In this video, we'll be looking at the geometry of a circle. Specifically, we'll break down central angles, inscribed angles, angles formed inside a circle but the angle is not at the center or on the circle, and angles formed outside the circle. For this video, I will be using the TI-Nspire technology. In the software, I will click on the Content tab. When in the Content tab, I will select Math Inspired, and then I will choose Geometry, and under Category, I'll choose Circles. And for this video, we will choose the secants, tangents, arcs, and I'll go down to where it says secants, tangents, and arcs, TNS, and double click. This will load the TNS file in my TI-Nspire software. In this file, I can now explore secants, tangents, and arcs. I can advance to the next page by pressing Control right arrow, and on 1.2, I see this breakdown of the measure of a major arc versus the measure of a minor arc. And as I grab point A, I will notice how it changes once you exceed 180 degrees. Control, right arrow, and now here on 2.1 I can grab and move point P to explore the angles described at the beginning of this video. Grabbing point P and putting it at the center of the circle, we notice that the measure of the intercepted arcs and the measure of the central angle are equal. I can grab point Q, and as I move that value, again, a central angle is equal to the length of the intercepted arcs. Let's explore inscribed angles. Grab point P and put it on the circle. You can now grab either point Q or point R, and as you grab and move, you will notice that the inscribed angle QPR is equal to 1/2 of the intercepted arc CUD. Now, let's look at angles formed inside the circle, but the angle is not at the center or on the circle. Grab point P and reposition it someplace in the circle, again, not at the center and not on. Now, select either point Q or point R to grab and move to see the relationship for this angle. This is a good example. 50 plus 34 is 84. 84 divided by 2 is 42. So the sum of the intercepted arcs divided by 2 equals the angle formed by those chords. Now let's explore the angle formed outside the circle. Grab point P, reposition it outside your circle. You can see two intercepted arcs create this angle. The bigger arc is 102. Smaller arc is 42. 102 minus 42 is 60. 30 is half of 60. 1/2 the difference of the intercepted arcs. I encourage you to play with this TNS file and see that this all holds true when you have a tangent and a secant, or possibly two tangents. Put point P inside the circle in different locations, and you will notice all of our rules hold true.